that the charge is placed at the center of this cube to cover the upper part of the charge. So it will somewhat look like this. What will be the flux through the opposite side? Hello everyone, welcome to Alan Overseas. So continuing this special series in which you guys will be provided with 45 important topics in the 45 days, in which I'll be taking your physics portion. So in that, if we will talk about the today's topic, so in today's lecture, we'll be talking about that how we can calculate the electric flux through a cube. Okay, so starting from the basic most point, that if it is the body centered charge, and before starting with the exact calculation, let's somewhat discuss about the Gaussian law, okay, the Gauss law, which says that if you want to calculate the electric flux because of any charge distribution, then we can just simply cover it in the with the Gaussian surface, and the electric flux through that Gaussian surface will be nothing but the charge enclosed divided by epsilon naught. The flux will be nothing but charge enclosed upon epsilon naught. That's what will be the net flux. So if we will take our very first example, that the charge is placed at the center of this cube. So if I'll ask you the basic most thing to calculate the electric flux through the whole cube, so it will be simply nothing but the Gaussian surface is just this cube because it is the closed surface in itself. So the flux will be nothing but the charge enclosed, which is Q, divided by epsilon naught. So that will give me the complete flux through the cube, right? Now, on the other hand, if somebody is asking me to calculate the electric flux through just a particular face of the cube. So as we can see over here, that whatsoever will be the electric flux from this charge particle, that electric flux, those electric field lines basically will be, equally passing out from all the surfaces because the charge is at the exact center of the cube. So I can say that the charge is placed at a symmetrical point so that the electric field lines will be ejecting out symmetrically. So if I'll calculate the flux through a particular phase, then it will be nothing just Q by 6 epsilon naught, because Q by epsilon naught was the total flux from the whole cube, and we know that the cube has 6 faces. So from one such phase, the flux coming out will be Q by 6 epsilon naught, right? Moving on to the next category. So it says that find the electric flux through the shaded area. Okay, so as you can notice that this shaded area is basically a square of side A, and the charge is placed at a height of A by 2. So as we know that if I want to calculate the electric flux using the Gauss law, so I need a closed surface, which is not present over here. So I'll have to close this surface so that I can use the Gauss law, right? So you must have studied that if I want to close this surface, so as you can see that if I will put 5 more sides with this square plate, then it will become a cube, right? If I will put 5 more square plates like this and arrange them, so it will become a cube. And you will find that since this is A by 2, so this charge is nothing but placed at the center of the cube. So it just simply became the last case. Okay, so in which you can say, if you will see this cube, so the charge is placed at the exact center. Since it is placed at the exact center, so I can say the flux through the cube will be nothing but charge enclosed divided by epsilon naught. That's what the flux is. And the question is asking just to calculate the electric flux to the shaded area, which is nothing but one of the 6 faces of the cube. So the flux through the face, or I can say the flux through the shaded area, will be nothing but 1 by 6 times the total flux. That means Q by 6 epsilon naught. That's it. I hope you got it. Moving on, let's see the face centered charge. That means the charge is on the face of at the center of one of the faces. Okay, so let's say this is the face, and on the center of which we have this charge Q. Again, if I have to calculate the electric flux because of this charge Q from this whole cube, I need a closed surface, right? I need this charge to be enclosed in the Gaussian surface, which is currently not, right? This charge is on the center of one of the faces. So it is outside, like half of it you can say that it is inside, but yeah, it is not completely enclosed. So if I want to do that, so what I'll have to do? I'll have to place one more cube over here. I'll have to place one more cube over here. So it will look like this, that the same cube, I have placed it over here. And if you will talk about the electric flux from the whole of the cuboid, this cube and this cube. This complete shape is basically a cuboid now. So flux through the whole of the cuboid is nothing but the charge enclosed inside the cuboid divided by the epsilon naught. But the question was not asking from the cuboid. The question is asking to calculate the flux through this cube. So since this whole of the flux is getting divided into two of the cubes, so flux through this particular cube will be nothing but q by 2 epsilon naught, half of this. That's it. So ultimately you just have to create a system in such a manner that the charge is enclosed and try to make it enclosed in a symmetric way. So it will be easier for us to calculate. Moving on to the next case, like it is the edge centered charge. As you can see that the charge is on one of the edges. So again you can get the idea from the figure itself that if I want to enclose this charge in order to calculate the flux, so I will have to put one more cube over here. Okay, so it is basically one such cube. Okay, so it is placed somewhere over here. So if I want to close that, so I will have to put one more cube over here, but still it will not be completely closed because it is still open from the above. So I placed one cube, and if I want to close it completely, I'll have to place two more cubes above so that it can become a bigger cube, right? Like let's say if it is of side L, so now the whole cube will have side 2L, 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 2L like that, like 6, obviously like the 6 faces will be there. So the sides will be of 2L now. So you can imagine like two more cubes will be there and it will look like this. So this was the cube. This was the center of the edge. I placed one more cube like that, one cube above that, one cube to the side of that, so that it became a bigger cube. Okay. Now, for this bigger cube, you can simply see that this charge is exactly at the center. This charge is exactly at the center. So if you will see the total flux from this surface, not the surface, from this whole body, the combination of 4 cubes, so it will be nothing but the charge enclosed, which is q, divided by epsilon naught, right? And if I want to calculate the flux through just one cube, so it will be simply divided by 4 because this whole flux is getting equally divided in all the 4 cubes. So from the whole bigger cube, if the flux is q by epsilon naught, which is getting equally distributed in the 4, so flux associated with one of the cube will be basically q upon 4 epsilon naught. That's it. So I guess it's very easy, right? Moving on to the next case, which is the charge at one of the corner. So if the charge is placed at one of the corners, so again, guess how many cubes I need to cover it up. Since it is placed on one of the corners, so I'll have to place, this is one of the cube, on the corner of what I have a charge. So I'll have to place one more cube to the side, one more in front, another one to the side of that. So it became 4 cubes and 4 more are required to cover it from the, upper portion, right? As you can see, this was the cube, this was the charge placed. I kept one more cube over here, one behind that, one besides that, and I need 4 more from the, to cover the upper part of the charge. So it will somewhat look like this. It will somewhat look like this, so that now I have 8 cubes. 1, 2, 3, 4, 5, 6, 7 and 8 at the back. Like 4 like this and 4 on those 4. Okay. So total flux from this whole system, from this whole body, the flux will be basically charge enclosed upon epsilon naught. And if I just want it from one of the cubes, so I'll simply divide it with the total number of cubes. Like this total flux is from 8 such cubes. So I can say it in this manner as well, that if the flux associated with one of the cube is phi, so 8 times phi is the total flux and it will be nothing but charge enclosed upon epsilon naught. So flux will be nothing but charge enclosed upon 8 epsilon naught. That's it. Okay. Moving on to the next case, that if the charge is placed at one of the corner, like we are just elaborating this in more detail, this particular case in which the charge is at one of the corner. So if you will talk about the flux through a particular cube, we already discussed it, that it will be basically q upon 8 epsilon naught. Okay. But if you will see that this charge is basically placed at one of the corners. Electric flux is basically the number of electric field lines passing through a particular cross-sectional area, right? So this charged particle is basically ejecting the electric field lines. But if you will notice that this face, which is BFGC, and this face, which is not shaded, like 3 faces are there which are not shaded, BF, EA and FEHG and EFGH, like AE and DH as well, you can call it like that, like the above face, this face and the front face. There are three faces which are not shaded. Okay, so basically, so if you will see this charge which is placed at the corner, so you can see, like basically the electric flux is number of electric field lines passing through a particular cross-sectional area, right? So this charge particle is in the plane of the upper face, which is BFEA. Okay, it is in the plane of EFGH as well, and it is in the plane of the back face, which is BFGC. So no electric field lines will be passing, or I can say the penetrating, no electric field lines will be penetrating these three surfaces. So this flux is not getting equally distributed from all the six surfaces. No. This flux which is associated with this particular cube will be basically passing through only the three of the faces, which are ABEF, ABCD, CGDH and AEHD, like the other remaining three faces. The flux will be passing through only those. The flux will not be linked with the faces which are containing that point charge. The faces which are containing this point charge, or I can say the faces in the plane of what this point charge is lying, will not be having flux linked with this point charge. So I can say flux through the ABFE, BFGC and EFGH will be 0, and the flux through the other three remaining surfaces will be equally distributed among them. So it will be total flux of the cube divided by 3. So total flux of the cube was Q by 8 epsilon naught. So divide by 3 will be basically Q by 24 epsilon naught. So yeah, you just have to take care of this thing, that the flux will be equally distributed among all the faces only and only if it is the symmetrical distribution. Just like over here, we do not have the symmetric distribution, so the flux was not equally distributed among all the faces. Okay, you can see out of 6, 3 of the faces have 0 flux linked with them, and the remaining 3 have the equal distribution. So take care of that. So seeing this question now, which is saying that we have a cuboid of dimension 2L cross L, and a charge Q is placed at center of the surface with area 4L square. Okay. What will be the flux through the opposite side? That means what will be the flux through this side, which is opposite to the face on which the charge is placed. So how we will be doing it? First of all, in order to calculate the flux, we need a closed surface. The charge should be enclosed, which is not present over here. The charge is not enclosed. We need one more cuboid so that we can close it, right? So basically this is a cuboid of side 2L and L. Imagine if I will be keeping one more cuboid similar to this above it. So the sides will still be 2L, but the height will become L plus L again. Okay, height was earlier L, width and the length were 2L each. Okay, now if I'll keep another cuboid with the same dimension, so height will also become 2L, so it will basically become a cuboid now. Sorry, it will basically now become finally a cube. Okay, so from the cube, flux from the cube will be basically charge enclosed upon epsilon naught. Okay, it is asking flux through the opposite side. Flux through the opposite side. So when I'll be keeping one more cuboid, it became a complete cube, and the charge is exactly at the center. So the flux will be Q upon epsilon naught. Now I want flux through this face, which is one of the face of the cube. So flux through one of the face will be nothing but how much? 1 by 6 times flux through the whole cube, because there are 6 such faces. Okay, so I got the answer that flux through the face will be basically Q by 6 epsilon naught. So option number 2 will be the correct answer. Just wait, there is a common mistake which I have seen a lot of people performing that, which is that what they do is they simply calculate the flux through the whole cube, which is Q by epsilon naught. Then they say that the flux from the lower cuboid will be half of that, let it be phi dash. So phi dash will be Q by 2 epsilon naught, because flux is getting equally distributed in upper half and lower half. So lower half, the flux link will be Q by 2 epsilon naught, And now this q by 2 epsilon naught is getting distributed equally among all 6 faces, which is completely wrong. Reason being, because this q by 2 epsilon naught is not equally getting distributed because it is not the symmetric distribution. The charge is not placed at the center of the lower cuboid. The charge is not placed at the center of lower cuboid, it is on one of the faces. So it will not be equally distributed. So that method will be wrong. So till here it is right, but if you will do that, flux through the face will be 1 by 6 of q by 2 epsilon naught, then it will be completely wrong. Keep that thing as well in your mind. So the answer for this question is q by 6 epsilon naught, and that's the end for our today's topic. That's all from my side. If you still feel any doubts or any suggestions, feel free to reach out to me in the comment section. And don't forget to watch the whole playlist. The link to what is given to you in the description. Thank you so much.